Inequalities can be pretty straightforward, but they can also be a little bit confusing. Say you have something like this. Say you have 2 minus x over 2 plus x is greater than or equal to 1. Now you could solve it the traditional way of solving inequalities and solving equations as well, which is you could multiply both sides by 2 plus x. You get rid of the 2 plus x as the denominator on the left side, and you have 2 plus x on the right side. The thing with that, though, is you don't know if 2 plus x is positive or negative, right? That x could be a number less than negative 2, and that would make the whole denominator a negative, but it could be a number beyond negative 2, and therefore it will make the denominator positive. So you have to make those two cases. You have to take those into account. To do that, though, you would do a series of steps and not consider this inequality as it's written. You would rearrange it. All right. So the first thing you would do is to move all of the terms to one side so that you're left with 0 on one side. Okay. So you can move the negative 1 to the left side. You end up with 2 minus x over 2 plus x minus 1. That's going to be greater than or equal to 0. All right. And now you have a fraction and a term that's not a fraction, just a natural number on the left side. You can combine those by finding the common denominator. And you know that 2 plus x will be that common denominator. So you have 2 minus x at the top. And then since it's minus 1, you're going to have minus 2 minus x. That's going to be greater than or equal to 0. All right, so if you simplify the numerator, you end up with minus 2x over 2 plus x is greater than or equal to 0. This is the inequality you're going to work with. All right, so you can automatically see that if x equals 0, you're going to end up with 0 on the left side being less than or equal to 0 on the right side, which is true. Right? So x can be 0, that would make that true. But you also have to consider what would make the denominator 0. And you can automatically see that if x is negative 2, you get 0 for the denominator. All right? So you can write those in a number line. You could say you have 0 here and then negative 2. 0 will work, right? Because the statement will still be true. 0 is greater than or equal to 0. So you're going to write a circle on top of the 0 on your number line, and then you're going to fill it in to show that this works. That's a really big 0. Sorry, a really big circle. Let's draw a smaller one. All right. You're also going to draw 0 on the negative 2, but you're going to leave it open. Now, you're looking for the terms of x that would make the left side of the inequality, this right here, greater than or equal to 0. All right. And since these are the two numbers that, the two critical points, let's just say, you would pin some numbers less than negative 2, between negative 2 and 0, and then beyond 0, and put them into the left side of the inequality to see if you get a positive or a negative value. Okay, so if you, let's say negative 3, if you put negative 3 into the inequality, you'll end up with a negative value. On the numerator is going to be positive, right? Because negative 2 times negative 3, that's positive 6. Yeah. Negative times a negative makes positive. But at the bottom, you'll end up with negative 1. So the whole fraction is negative. The whole left side is negative, and that is not true, right? So here you have negative. If you put negative 1 into the inequality, you get a positive value, right? Because you're going to get a positive value for the numerator, and you're going to get 2 minus 1 for the denominator, which is positive. All right, so you have a positive between negative 2 and 0, and beyond 0, let's say 1, you're gonna have a negative number because any number plus 2 is going to be positive, but then any number times negative 2, that's going to give you a negative value. So you're going to have a negative here. All right, so as you can see, the only interval that would satisfy this inequality is from negative 2 to 0. Because those are the only values that will give you a positive result. So you could say, therefore, the solution is open bracket, sorry, not open bracket, circular bracket, round bracket, minus 2 to 0, and then square bracket. The square bracket is going to tell you that you're including that endpoint. And the round bracket is telling you that that's your other bound, your other endpoint, but you're not including it. That is the solution to this rational inequality. Here's another example. Say you have 2 over x plus 2. That's going to be greater than 3x plus 3. Similar to the previous example, you would use rearranging to move all the terms to one side and then have 0 on one of the sides. You can subtract 3x plus 3 from both sides, right? You're going to be left with 2 over x plus 2 minus 3x minus 3 is greater than 0. After combining like terms, you should end up with something like this. Minus 3x squared plus 9x plus 4, all of that over x plus 2. That's going to be greater than 0. Now, you're looking for the terms of x that would make the left side greater than 0. Okay, so now you look at your critical points, or you could call them your split points now, because that's where you're going to split that number line. That's where you're going to find your intervals. You can automatically see that the denominator is going to be 0 at x equals negative 2. If you do x equals 0, though, you're not going to end up with a satisfactory inequality, because you're going to end up with a negative on the left side of the inequality, and negative is not greater than 0. Okay, so just briefly, in your mind, you can do x equals 0. The first two terms of the numerator are going to be 0, so you have negative 4 at the top, and then at the bottom you have 2. So negative 4 over 2, that's negative 2. Well, negative 2 is definitely not greater than 0. So, using the quadratic formula, go ahead and find the number that would make the numerator equal to 0. Go ahead and pause the video and do that right now. Okay, so the numerator is 0 when x is equal to negative 9 plus minus square root of 33, all of that over 6. And since you have plus minus, you're going to end up with two values. So these are going to be approximately negative 2.46 and approximately negative 0.54. All right, since inequality uses a greater than symbol, and 0 is greater than 0 is false, you're not going to include 0 in your split points, right? Because it doesn't satisfy the inequality. It's not part of your solution interval. After choosing suitable test points and determining the sign of the left side of the inequality, the signs of the left side of the inequality, right? You have negative 2.6, negative 2.46, you have negative 2, and negative 0.54. You should have the following signs above the intervals. You're going to draw the circles. Since you're asking for greater than and not greater than or equal to, you're not including any of those bounds. You're not including any of the split points. Looking where the positive symbols are located, it's going to give you the following solution. You have round brackets, minus infinity, negative 9 minus root 33 over 6, and then union with negative 2 to negative 9 plus root 33 over 6. All right? Those are the only intervals that will give you a positive value for the left side of that inequality. When writing the final answer, we use exact expressions for numbers in mathematics, not approximations. That's why you write the fractions, which are the exact expressions for the numbers.